Hello everybody, welcome to today's class, and in this class we are going to be discussing a very interesting topic. Why is it that sodium plus chloride, right, coming together, which is sodium chloride, will give us what? Salt. Why is it possible that it is sodium plus chloride coming together that will give us what? Our normal salt, the Dangote salt to buy in the market. Why is it that it is what? Sodium plus what? Chloride coming together that will give us our sodium what? Chloride. And why is it that hydrogen plus what? Oxygen coming together will now give us what? Hydrogen plus oxygen coming together will now give us what? Water, right? Why is it so? So why is it hydrogen plus what? Oxygen giving us our what? H2 what? O, right? Why is it what? So why is it that these things are what happening? And this is because of the concept that is known as what? Chemical combination or chemical what? Bonding. So in throughout them, what is what? Chemical what? Combination, or what is what? Chemical what? Bonding. When we hear the term bonding or what? Combination, it is not what rocket was science. It is simply saying how combine, like something will now come what? Together, right? We know the concept of what? Bonding, a man bonding with what? A woman, right? So that is just what? How what it is. When you bond with a particular thing, that means you what? Interact what? Together. That means there's something you are gaining from that person. There's something you are gaining from that person, and there's something that person is gaining what? From you. Or there is something that person is gaining from what? You. Or there's something you alone you are bringing that that person is going to gain, and you are also going to gain from what? It. With this simple illustration that I have just done, I have talked about what? The types of what? Chemical what? Combination. But let's not just rush into it. We are going to take it step by what? Step. My name is Basi Ejogba. I'm a student in the University of Calabar studying medical laboratory science. And in this channel, I help students level up their academic game. I also share footage on this channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so I can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like I've said, what is the concept of what? Chemical what? Combination. How come two elements are coming together in order to give us what? A compound, right? And why is it that it is of those particular elements that are what? Coming together? Why is it not sodium and other what? Elements giving us our what? Salt? And why is it particular sodium what? Plus what? Chlorine, right? So now what is what? Chemical what? Combination, or what is what? Chemical what? Bonding. Chemical combination can be simply be seen as a process. So we say this is a process. This is a process by which atoms join together. By which atoms join together. We can say simply atom joins together. We can simply say atom join, right? To form molecules. To form what? Molecules, or what? Compounds. Form molecules or what? Compound. Form molecules or what? Compound. Right? This is a very interesting topic, and I want you to follow up step by what? Step, or process by what? Process. Say this is a process by which what? Atoms join to form what? Molecules or what? Compound. And why is it that atoms will join together in order to give us what? A molecule or what? A what? Compound. This is because all the major reasons, all the major purpose of chemical bonding is so that these two elements, or these three or four elements, will what? Attain a concept which is known as what? An octet state, which is known as what? An octet state, or what? A duplet state, a duplet what? State, or what is also known as what? Stability, right? Which is also known as what? Stability. That means the major purpose of chemical bonding is for element to what? Attain what? An octet state, a duplet state, or what? Stability. We already know that octet simply means what? 8, right? Which is a balanced state. 2, duplet means what? 2, which is also what? A balanced state. And we already know the concept of the English definition of what stability is all about. So that is the major reason elements undergo what? Chemical what? Combination. So in the same vein, let's talk about these types of what? Chemical what? Combination. Although I've already talked about it in the introduction of this video, when I was trying to tell you the major reason of what? Bonding. Why two people come together to what? Bond. It is because there's something they are going to benefit from what? Each other, right? But there are some settings that only one person will benefit. Let's say, okay, you are in school and your parents, you need money from your parents. What they simply do is to transfer you that money, right? They transfer you that money, right? And the major reason they are transferring you that money is because the both of you have what? A common what? Course. Your parents and you in the university have what? A common course, which is for you to what? Further finish your education, have a good life, and also come and what help them in their what old age, right? That is what is happening also in chemical what bonding. So we say the types of chemical bonding. So we say types of what bonding. So we simply say types of what bonding. So the moment you hear bond, you simply know that what I am talking about is what chemical what combination or chemical what bonding. The first type of chemical bonding or chemical combination we have here is what the electrovalent. We have the word electro what valence. We have the word electrovalent. It is not just only known as electrovalent, it's also known as what the ionic bonding. So we have the electrovalent or the what ionic what bonding, right? Now this is a type of bonding that happens, right, involving the transfer of electrons. So this involves the transfer of electrons. This involves the transfer of electrons. Take note on the what I am dragging, right? The transfer of what electron. Transfer here is the keyword when it comes to what electrovalent or what ionic what bonding. It involves the transfer of electrons, right? It doesn't just involve the transfer of electrons between metals and metals. Rather, it involves the transfer of electrons from metals to non-metals. So say from metals to what the non-metals, from metals to the what non-what metals, right? So that is what ionic or what electrovalent bonding is all about. Now we are talking about ionic bonding. That means ionic bonding is derived from a concept that is known as what ions, right? When you hear ionic bonding, that means cleaning the IC give us what ions. What is ion? We already know that ions are what charged what particles. So ions are what these are what charged what particles, right? So when we say charged particles, it can either be what positive charge or negatively what charge. It can either be what positive or negatively what charge. Now when it comes to the concept of what the electrovalent or the ionic bonding, which involve the transfer of electrons from the metals to the non-metals, and we say ions means what charged what particles, which is what either negatively charged or what positively what charged. The metals are the what positively what charged. Take note, the metals are the what positively charged and the non-metals are the negatively what charged. Why is it that we will assume or we will say the metals are the positively charged and the non-metals are the negatively charged? This is because in the concept of the transfer, it involves the transfer of these metals of electrons from the metal to the non-what metal. When the metal gives out what electrons, when this metal gives out, like it donates, it transfer it what electrons, the metals become what electropositive. So when it gives out electrons, gives out what electrons, it is what electropositive. So when it gives out electron, it is what electropositive. And when it collects electron, it is what electronegative. That means electronegative, right? That is what we are talking about. Electropositive, that means the electron is going to be what positive, or the electron is also going to be what negatively what charged. So that is basically everything you're supposed to know when it comes to the what electrovalent what bonding, right? So valence electrons, right? So let's talk about this electron. What is electron? Remember when I was talking about the atomic structure and I was talking about the subatomic particles, I talked about the electrons and I said in our next class we are going to talk about what electrons, right? And I said we have a cycle, right? Remember our last class talked about atomic structure. If you're yet to watch that video, go and check it, the atomic structure, right, and electronic configuration. Check it out. I say we have what a cycle, right? This is not just a cycle, but this is what is known as what an orbital, right? This is what is known as what an orbital. Now, what is what an orbital? Note in chemistry, an orbital is a region of what space. So we say an orbital is a region of what space. It's a region of what space where there is a 98% probability, of finding what an electron, where there's a 98% probability of finding what an electron, So when we see a cycle like this in chemistry, we already know that this is what an orbital, and it's a region of space where there's what a 98% probability. That means the probability of us finding an electron in an orbital is very, very what high. So if this is an orbital, if you get to see those asterisks or the stars, right, residing in the what outermost what shell, of this what orbital, that is what is known as what electrons, right? This revolving around the what shell of what an orbital is known as what the electrons. It can also be known as also what as the valence what electrons. So the electrons revolve around the what orbitals. Remember I said the protons is found inside the nucleus, the neutrons is found inside the nucleus, but the electrons is not found inside the what nucleus. The electrons is found what around the what orbital, right? That is what valence electron is all about. So let's talk about the characteristics of this what electrovalent or what the ionic what bonding. Let's talk about the what characteristics of this what electrovalent or what the ionic what bonding. The number one characteristics is that it has what a high melting and what boiling what points, right? Say x's, right? So say number one, high melting and boiling what point. You say it has a what high melting and boiling what points. So we'll just be listing them down. We have a high melting and boiling point. We also have what solubility, right? It's what soluble. So we say solubility. Now note that electrovalent bonding or electrovalency or electrovalent what element, right? Or element that undergo what electrovalency dissolves in what water. So when we say solubility, they dissolve in water. They dissolve in what water. They dissolve in water, right? They dissolve in water. Using a popular example, which is what our sodium what chloride. Now, if you find out that the sodium is what positively charged and the chlorine is negatively charged. Why is the chlorine negatively charged and why is the what sodium positively what charged? This is stem from as a result of the what relative what atomic what mass. Right, this is stem as a result of the what relative what atomic mass. That is why the chlorine is what negatively charged and the what sodium is positively what charged. Now, when we talk about the electronic configuration, check our last class when we're talking about the electronic configuration. You will get to understand why this is like this and why they are soluble in what water. Right. So note that all what electrovalent compound dissolve in what water. They are soluble in what water, and they are also what electrolyte. So say number three, they are also what electrolyte. When we say that electrolyte, it simply means that they can conduct what electricity, right? So liquids, please note, liquids that can conduct electricity, liquids that can conduct electricity, liquids that can conduct what electricity, liquid that can conduct what electricity. Any liquids that can conduct electricity is known as what electrolyte. Please note, liquids that can conduct electricity is known as what electrolyte. So this is basically everything you're supposed to know when it comes to the what ionic bonding or the what electrovalent what bonding. Let's move on to another interesting what bonding, right? And this is the what second type of bonding. Now this second type of bonding is one that interests me a lot because it tends to confuse students also a lot, right? Now this is known as the what covalent what bonding. So we say number two, which is the what covalent what bonding, right? Now this covalent bonding is at times divided into two, or is basically divided into two, although some textbooks talk about it separately. But for the purpose of your exam, we are going to talk about them as what we are going to talk about them separately. We are not just going to link them up so that you will not get confused when you tend to see questions based on this and the options are now what confusing. So when it comes to the covalent bond, this involves the what sharing of what electrons. So this simply what involve what sharing of what electrons. Please take note of the key point. Remember, for the ionic bond, which involve what the total transfer, but for the covalent bond, it involve what sharing of what electrons between what non-metals. So this is between what non-what metals, right? So it is not involving metal and metals. It is not involving metals and non-metals, but rather it is involving what non-what metals. Now also note that it can be what a single bond, it can be what a double bond, or what it can be what a triple what bonding. Now let me give you a cheat code. The moment you hear covalent bond, the first element that should come to your mind should be what carbon, right? The moment you hear covalent bond, the first element that should come to your mind is what is known as what carbon. Although I'm going to discuss more about the carbon when I'll be talking about the word carbon and it what compound, where we are going to discuss in-depthly talking about what catenation and the special properties of what carbon. But just know that carbon is the one of the elements that undergoes what covalent what bonding. Now it is not just carbon alone, even oxygen undergoes what covalent what bonding. And the type of covalent bonding that this oxygen undergoes is what a double covalent what bonding. So we have our what O2, right? So we have our what O and we have our what O. Right? So this is our what O2. Note that the major purpose they are undergoing this covalent bonding, or the major reason they are undergoing bonding, is so that they can attain stability. Please don't get lost, right? Don't get lost. Always have the purpose, or always know the purpose why they are undergoing this what bonding. They are undergoing bonding because they want to be balanced. I want to be balanced. You too want to be what balanced, right? Now also, talking about this covalent bonding, we have a special type of covalent bonding which is known as the what coordinate what bond, right? We have the coordinate bond. Now it is not just known as the coordinate bond alone, it's also known as what the coordinate or the dative what bond. It's also known as the what coordinate and the what dative what bond, right? This is a special type of what the covalent bonding, but in this case it involves the presence of what a lone pair what electron. It involves a lone pair what electron. It involves a lone pair what electron. It involves a lone pair what electron. What this simply means that when it comes to the coordinate or the dative bond, it involves a lone pair electron, in a sense that it is one element alone that is bringing out its electron. Now it's not just bringing out the electron to donate, rather it is bringing out the electron so that it can still share. So what this is simply means give and what share. A give and share what bonding. Please take note, the give and share bonding is what is known as the what the coordinate or the what covalent what bonding, right? Now talking about, let's discuss about their properties. So we are going to be talking about the characteristics of the covalent bond and the coordinate bond, the coordinate or the dative bond. Now it's also known as the coordinate covalent bond or the dative what bond. Now one of the special properties or the characteristics of the covalent bond is that concerning its what solubility. Now it is soluble but not in what water. It is soluble but not in water. It is only soluble in what non-polar what solvents, and we know that water is what a polar what solvent. So covalent compounds will not dissolve in what water, and also they are non what electrolytes. That means they cannot conduct what electricity. Although there is an exception which is what graphite, but we are not going to talk about it in depthly in this particular topic. We are going to be talking about it when we'll be discussing about what carbon and its what compound, which we are going to be discussing about the what allotropes of what carbon, right? So let's move on to the next covalent, to the next, sorry, let's move on to the next bonding, which is number 4, which is our what metallic what bonding. Now when you hear the concept or when you hear the name metallic bonding, it simply happens between what metals, right? So this is number 4. We say what metallic what bonding. It's our metallic what bonding. This happens between what metals. This happens, this happens between what metals. Please take note for you to see how this is going. This is very, very interesting. The first one, which is ionic, happens between metals and non-metals. The second one happens between, the second, which is the covalent, happens between non-metals. But this last one, or this fourth one, which is metallic bonding, happens only between what metals, right? So if you are following up this class, drop it in the comment section. Answer this question: what is conductivity? What is conductivity? Drop your answer in the comment section. Let me know if you are following. What is conductivity? What is ductility? What is ductility? And what is malleability? And what is malleability? Drop it in the comment section, the answers. What is conductivity? What is ductility? And what is what malleability? Drop it in the comment section. Let me know if you are actually what following. And let's talk about the last bonding, which is also very, very interesting. Is the water we drink, right? Which the water we drink undergo which type of what bonding, right? And the water we drink, please note that the water we drink undergoes what a sweet type of bonding, a special type of bonding, which is known as what hydrogen what bond. So it undergoes what is known as what the hydrogen what bond, right? What is hydrogen bond? The hydrogen bond is an intermolecular force, right? This is what an intermolecular what force. This is an intermolecular what force. This is an intermolecular what force, which arises when hydrogen is what covalently what linked. This intermolecular force, which arises when hydrogen is linked, like this hydrogen is covalently linked to elements like nitrogen, oxygen, and what fluorine, right? Because my marker is getting dim and dim and dim. So this is an intermolecular force which arises when hydrogen is covalently linked to elements like what nitrogen, hydrogen, and what hydrogen to nitrogen, oxygen and what? Fluorine, right? So this is the what? Hydrogen what? Bond. Now the hydrogen bond, please take note, the hydrogen bond is common and popular in what? Water. So it is common and most popular in water, and most popular in our what? Water, which is our what? H2 what? O, right? It's most common and popular in what? Water, and it is the most, it is most strongest, it is very very strong, strongest in what? Hydrogen what? Fluoride. So it is strongest in hydrogen fluoride, but it is common and most popular in our what? H2O. So this is everything you're supposed to know about what? Covalent what? Bond, about what? Chemical combination or what? Bonding. We are not going to enter in depth, right? But as you finish, if you finish your your JAMB exam, you smash it and you get admission to the university, you are going to get the A-level understanding of chemical combination and what? Bonding. We have talked about what chemical bonding is all about. We have talked about the reason of chemical bonding. We have talked about what the major reason why they undergo this word bonding, and we have talked about the types of what? Bonding, which is the ionic and the electrovalent bond. Talked about the coordinate covalent bond. We have talked about the covalent bond. We have talked about the metallic bond, and we also talked about the what? Hydrogen what? Bonding, and there are various what? Characteristics. So this is just how it's going to be, and like I said, for every class we finish, we are going to solve past questions on it. So make sure you subscribe to this YouTube channel and also share this video to your friends so that they can come here and get value, so that in turn, when we start dropping past questions based on topic by topic which we are treating here, you will not be left lost, or you will not get lost without following up. If you love this video and you wish to continue getting updates like this, like I said, please feel free to hit on the red subscribe button. And if you want to join our private group, our private WhatsApp group, where we have intense discussion, where you can get clarifications on anything that is bothering you based on chemistry, physics, biology, mathematics, and your use of English, including your lucky headmaster, then you can chat me up to register in our class at an affordable rate. And like I said, until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a setter. I really love you. Thank you.